Right. In this session, we want to discuss two important names, sample space and event. What is a sample space? What is an event? Uh, Sample space is basically a collection of all possible outcomes. All right. And they are basically unique, and therefore we can use a set notation uh, to denote what is a sample space. So in short, a sample space is a set of all possibilities, right? Possibilities, not probabilities, possibilities. So we're not just trying to play with words here, but the word possible means that it may or may not occur, but there is a potential for it to occur. So we might include uh, very extreme values that in all common sense of assessment we do not think that it is likely to occur, yet it is possible, right, um, to happen in our measurement. Then we put it in and we call that part of our sample space. So a collection of all possibilities, and of course, because it's a set, all items in the set will be unique, and that means only one copy of that particular description, then that will be our sample space. Okay, so it is quite a a very strange name to say sample here, and again very misleading, I would even say, to beginners learning these terms, because we just talked about what is population and sample, and then we now talk about sample space, and this sample space actually can be understood as population space because it's like a collection of all possible outcomes that a population measurement can take up or take on. So this is really uh, a very tricky name, or I almost said the word dangerous name, because it's very dangerous for beginning learners to misunderstand this completely and be kind of like forever confused, right? So my suggestion, very strong suggestion, is that you just understand this two-word name, sample space, as just a name. All right, it just describes the set of all unique outcomes, even if they are duplicated. And because we are writing in a set notation, all labels, all numbers, all values will be having just one copy, and so will be unique anyway. So the word unique here is just to stress that when you write it out, it is basically one copy. And why is that important? Because sample space goes to the x-axis. Remember your histogram, all right? So if we draw a histogram, sample space goes to the x-axis. Keep that in mind, right? We never draw a histogram or any other gram with the sample space on the y-axis. It will, I mean, you can purposely try to draw it, but it is, say in a scatter plot, that might be possible. But in most of these exercises and problems that we encounter, sample space, all the unique items basically are laid out on the x-axis. So here, for example, we have a sample space of throwing a dice, and because all possible numbers that can come out will be 1 to 6, so we'll label that on the x-axis, right? So those labels don't go to the y-axis unless we're talking about joint distribution, all right, and we're talking about scatter plot analysis of two variables or more, then yeah, all right, the y-axis will also be sample space of another measurement, but the x-axis is still having the sample space of the x measurements, right? The y-axis will be having the sample space of the y measurements. And now you understand when I say sample space, simply, oh, it is the set of all possible unique outcomes of the y measurements. Say, for example, we are measuring the dice, right? So we throw the dice many, many times. And what are all the possible unique outcomes? 1 to 6. Now, can we put in 7? Yes, because it's possible, but then we do know from the construction of the dice that it is six-sided, right? So basically, we already know upfront that it is impossible. It is basically 0. So while it is not wrong technically to put in 7, 8, 9, 10, it just confuses and annoys your reader. Yeah. So because everyone knows it's a six-sided dice. But if you say, nope, my dice actually is 10-sided, it's a 10-sided dice, then fine. Then your sample space will be 1 to 10. And you are supposed, you must write in 1 to 10. Okay, so for those outcomes whose probabilities are known to be 0 for sure, because of our knowledge of the construction or the setup or the measurements or the device, then yeah, you can just drop them out. But technically, again, possible simply means whether the probability is 0, 0.1, 0.2, or even 1, you can put it in the x-axis. All right. So now that we understand that sample space, most importantly, has got nothing to do with sample, right? Sample is just sample. Sample space is just collection of all possible unique outcomes and can describe all the unique outcomes of a already captured sample measurements, all right, or the possible unique outcomes of a population. Yeah, for example, what's the average income of Singaporeans in 2020, right? My our well-known favorite example. It could be all integers, but how about cents and 10 cents and 50 cents, right? So it will be all real numbers from, let's ignore owing people money because if you're talking about income, right? So minimum income is 0. If you borrow money from others and you end up ending the year with a negative income, that's a different story, right? So from 0 to, well, is it possible that people earn infinite amount of money? Let's put aside the philosophical argument, right? But no, right? Not mathematical infinity. But we can still drag it on to infinity, just so that if people end up earning $1 billion a year or $1.5 billion a year, we can still have it in our sample space. So we might just conveniently pull it all the way to infinity. Okay, get that? Because we cannot prove that there's nobody getting such a high income. We cannot rule out the possibility, right? And the probability might not be very high, but it's possible, right? So we just put it in just to avoid unnecessarily lengthy and unneeded kind of debate.